So what if the future of AI isn't one giant superbrain, but a whole team of specialized AIs all working together? Well, that's the big idea behind a new framework called TUMIX, and honestly, it could completely change how we solve the most complex problems. Let's dive in.
Okay, imagine this. You ask a single AI to do all of this at once. Plan a huge project, figure out the budget using live, up-to-the-minute data, and then actually write the code for a website for it. Each of those steps needs a totally different skill. You've got strategy, then precise math, then creative coding. This is exactly the kind of thing that pushes even our best AIs to their absolute limits.
And the reality is, even a powerhouse model, like a Gemini or a GPT-4, can seriously get tripped up here. It might be amazing at planning the project part, but then just completely fall apart on the real-time budget calculation. So the big question is, why? Why does that happen?
Well, it all comes down to a fundamental problem you could call AI's tool trouble. And it's really all about the difference between thinking and, well, doing.
So here's the heart of the problem. Large language models are brilliant thinkers. They get context, they get common sense, but ask them to do some precise math or pull live stock data, they really struggle. Now, on the other hand, you have tools like code interpreters and search engines. They're perfect for those jobs, but they don't have that creative, common sense reasoning. The real challenge is getting the thinker to know exactly which tool to use and when, and that's where things often go wrong.
So, if one AI working alone struggles, what's the solution? Well, the big idea here is actually pretty simple, but it's incredibly powerful. You just don't rely on a single AI. You build a team of them.
And that brings us to TUMIX, which stands for Tool Use Mixture. It's basically a framework where instead of one AI tackling a problem, you have a whole squad of them working in parallel, and each one has its own unique strategy. But the real magic, the part that makes this so cool, is when they start sharing their results with each other.
The best way to get this is to think of it like a committee of human experts. You've got the thinker, who just uses pure logic. Then there's the coder, who's going to build tools with Python. You've got the librarian, who goes out and searches for the latest facts, and the guide, who tries to pull it all together. And the core idea here is so simple. This diverse team is always going to outperform any single genius working all by themselves.
So how does this AI committee actually get the job done? The process is brilliantly simple, but it's also incredibly effective. It's all built around this collaborative loop.
The whole workflow is just a simple three-step cycle. First, every agent, the coder, the librarian, all of them, takes a crack at solving the problem on their own. Next, they all share their answers in a common space, kind of like a virtual whiteboard. And then, here's the most important step. Each agent looks at what everyone else came up with and reevaluates its own answer based on those new ideas. They just keep repeating this loop, getting smarter and more accurate with every single round.
And this really gets to the core finding of the research. The key to better AI performance isn't just about building one massive, super-scaled model. It turns out it's about building a team with diverse skills and high-quality members. Diversity actually outweighs sheer size.
Okay, so the theory sounds great, right? But the proof is always in the performance, and the results here are pretty staggering, actually.
So, on this super challenging benchmark called Humanity's Last Exam, and yeah, it's designed to test AI on really tough problems, from engineering to social sciences, the results are just crystal clear. TUMIX hit an accuracy of 32.3%. That's a huge jump from the 29.5% of the previous best method. That might not sound like a lot, but that is a measurable leap forward on some of the hardest problems we can throw at an AI.
But it's not just about being more accurate, it's also about being way more efficient. And that brings us to this number, 49%.
That 49%, that represents a massive leap in efficiency. See, the system has this AI judge that's watching the team's progress. As soon as that judge is confident in the answer, it just stops the process. This means TUMIX can get its best result using only about half of the computational power it would take if it just ran the full process every single time. It's not just more accurate, it's way smarter with its resources.
So what this all points to is a really major shift in how we might build powerful AI in the future. It really is about being smarter, not just bigger.
And this leads to a fascinating, almost meta question. If this team approach is so good, could you actually use an AI to dream up even better, more creative team members?
And the answer is a huge yes. The researchers literally prompted an LLM to invent entirely new types of agents, and it came up with these creative roles like a debate agent and a hypothesis pruner. When they added these AI-designed agents to the team,
TUMIX's performance got even better. This is a system that can literally learn to improve itself. It's incredible.
So, what's the big takeaway from all this? The future of AI might not be a single, giant superintelligence. Instead, it looks more like orchestrating these brilliant teams of specialized, collaborative AIs. And this isn't just some clever trick. It's a real path toward AI that is fundamentally more accurate, more reliable, and way more efficient.
Which, of course, leaves us with one final, very exciting question. If the future of AI really is a super team, what grand challenges should we set for them next? Curing diseases, solving climate change, pushing the absolute boundaries of creativity? The possibilities are really just beginning to unfold.